On this next page of our notes, we are reading solubility charts. So first of all, to remind you about solubility, it says the amount of solute that will dissolve in a given amount of solvent at a specified temperature and amount. And the amount, we're going to measure that as mass. But it's given as mass of solute per 100 grams of solvent. So when you are defining this, your graph will give you a specified amount of solvent. So in this one, it is per 100 grams of water. So it's grams of solute per 100 grams of water. If we were to change the amount of water that we're using, we can no longer use this graph. So you'll notice that all of these questions, it says something in 100 grams of water, in 100 grams of water, in 100 grams of water, in 100 grams of water. So that's basically just telling you, hey, this graph is like calibrated to that amount of solvent. There are 3 types of solutions, or 3 ways that we're going to classify them. I'm going to start with B, which is a saturated solution, because I think this one's the easiest to define. A saturated solution is going to be a solution that contains the maximum amount of solvent at that given temperature and amount of solute. Or sol. I think I said that backwards. Maximum amount of solute at a given temperature and solvent. Maybe that's the only one I messed up. Okay, so contains the maximum amount of solute, stuff dissolved, at given temperature and amount of solvent. So, for example, if you wanted to make a saturated solution of sugar water, if you took 100 milliliters of water or 100 grams of water, and then you took a scoop of sugar and put it in there, and then another scoop of sugar and put it in there, and another scoop of sugar and put it in there, and you kept on doing that, and every time it's dissolving, and it's dissolving, and it's dissolving. At a certain point, you are going to reach the maximum amount of sugar that that solution at that temperature can hold. That is the point that we would call it a saturated solution. So it is the maximum at that temperature at that amount. If you were to add more water, if you change the amount of solvent that you have, then you would change the amount of sugar that you're able to dissolve in it, so you're no longer comparing the same thing. Make sense?
It's saturated when there's more sugar than water?
No, it is saturated when you have the maximum amount that is all able to dissolve at that temperature and amount of solvent. So in a saturated solution, all of the solute is still able to dissolve.
What is that?
It's the maximum amount. So everything is dissolved, but it's the maximum amount that can dissolve. So it's like kind of a fine line. Anything over that, if you figure out the maximum amount that's able to dissolve in a certain amount of solvent at a certain temperature, and you put more, then what you would be left with is excess solute, undissolved, usually just sitting at the bottom of your container. So a supersaturated solution contains more than, that says more than the maximum amount.
No, honey is actually a supersaturated solution, but the reason why it's all still kind of dissolved is because it starts out with a much greater volume of solvent, and the solvent is just evaporated.
So that is actually what we're doing with our, well, kind of what we're doing with our lab today. So a supersaturated solution contains more than the maximum amount of solute at a given temperature and amount of solvent.
That's kind of why honey actually kills pretty much any like fungus or bacteria in it, so it never goes bad. It just dehydrates them because it pulls the water out.
I didn't realize that.
Yeah. Like archaeologists have found perfectly edible honey in ancient Egyptian tombs.
Ooh, I'd be eating that honey. I'll put that on my biscuits.
It's still not suggested to eat it at all.
So my example that I like to use for a supersaturated solution is if you, like, I feel like everyone knows this kid who is, like, unhinged enough that, like, when they're making Kool-Aid, they do not follow the directions at all, and they're just like, yeah, add the sugar, and then they just keep on pouring it, and then they're adding so much sugar to the Kool-Aid that at the bottom of their Kool-Aid, there's just, like, a layer of sugar that no matter how much you stir, no matter how long you let it sit, it's not dissolving because they've added too much.
Is that why that happened?
Yes.
I never.
Do you know what I'm talking about?
Yes.
That is called a super saturated solution. You have more than what is able to dissolve in that amount of water at that temperature.
Wait, so if you were to get rid of like all the sugar water, it would be like just dry sugar down there? But it like, yeah.
It would be dry. It would be.
I mean, it would be wet still unless you
Well,
dried
yeah.
it.
But
Okay, so let me finish
if you-
this.
If you got a towel.
No. All right, we're done. So, a supersaturated solution. Generally, if you don't do anything to manipulate it in some way, what's going to happen is you're going to, in general, see the solute undissolved at the bottom. It's going to just sit there. So, like the leftover Kool-Aid powder or sugar sitting at the bottom. However, we can manipulate it by changing the temperature and forcing that excess solute to dissolve. That is what we're doing in our lab today, is we're going to take this, we're going to make a supersaturated solution of borax by taking the amount of borax that I give you. You're going to try to dissolve it in your water by stirring it. It's not going to all dissolve because it is purposely too much that can dissolve in the amount of water that you're using. Then you're going to heat up your solution, which will allow, so since it's a different temperature, you are actually able to dissolve the borax at the higher temperature. And then we're going to let it sit where it comes back down. So after everything dissolves at that higher temperature, we let it come back down from the hot temperature to room temperature again, where that amount of solute can't actually dissolve, and that produces a crystal. So we can get it started with something. So we're going to use pipe cleaners as kind of our like seeder for this. And crystals will form on the pipe cleaner because of that solute trying to come back out of the solution.
How long does the lab take?
Hopefully less than 20 minutes. All right, and then an unsaturated solution is going to be a solution that contains less than the maximum amount of solute. So in an unsaturated solution, you can continue to add more solute and it's going to continue to dissolve. The difference between that and a saturated solution is that in a saturated solution, if you add more, it's not going to dissolve because you're already at the maximum amount. So unsaturated, less than the maximum amount. Saturated is the maximum amount, and supersaturated means more than the maximum amount. This one is only confusing because if you manipulate the temperature, you may or may not see dissolved solid in it, or undissolved solid, sorry. So usually if it's just supersaturated, I'm trying to rush and get my words mixed up. If you have a supersaturated solution, generally you would see undissolved solute at the bottom of your container or left over in there, not dissolved all the way. But sometimes we can change that a little bit. So we'll stop there for the sake of time.